Welcome, ladies and gentlemen. The topic is on flash floods. There have been a lot of flash floods all over the world in the recent years, and also, of course. And we have been thinking now about the main question: is this getting more severe, and what is the problem? So, and what is the effect of anthropogenic activities? So first, are they really increasing? Do flash floods increase? So what is a flash flood? Coming back to this, a flash flood is a usually local flood, a few tens of square kilometers or maybe hundreds, but not more. So rainfall intensity is not the amount, the pure amount of water pouring down from the sky. It's the time. So in short time, so usually we say if it's 6 hours or less between the peak rainfall and the flood, we call this a flash flood. And of course, the warmer the air is, the more likely is that you have convective thunderstorms causing such a flash flood. This is a map of the observed change in heavy precipitation since the last 50 years, more so, 60 years actually. And you see that in some regions, the number of heavy rainfall increased by about 70%, which is a lot. In other regions, especially in the southwest, it's increased much less. So, and even in Hawaii, if one can count this, there was even a decrease. Of course, this can be an artifact by observations, but I think we have observed such cases in many parts of the world. Can you please go to the next? Yes, this is in southwest China. Also, this for about 60 rainfall stations, measurement point rainfall stations, and it's the left is the amount and right is the frequency of precipitations, and these categories are the higher the category, the higher the intensity is. That means it's the change. That means that the amount of heavy rainfall is increasing, and also the frequency of such high classes, the classes 8, 9, 10. Next one, please. And these are three just examples. It's floods in Catalonia, which is the northeast of Spain, where Barcelona is the capital. And one can see that there's maybe some trend, but it's not a strong trend. The main problem is in flash floods, referring observation, that I would claim that many of such floods are not observed. I mean, especially the rainfall for these floods is not observed. That means network, one observes more. And here in this regard, there was a particular observed trend. Let's go to the next, please. So let's look what are the processes. We do process research here, not only statistics and data analysis. So first, next one, of course, we need high rainfall intensity. Please, can we have the next one? Is this working? Okay, the processes of flood formation. Well, high rainfall intensity, this is in Germany, in southern Bavaria. And this was a high rainfall intensity rainstorm about 5 years ago. And this caused a lot of damage, even some people died. Okay, we have been here. So the second point, because some, especially meteorologists, they tell us that the main feature is, the only important point is rainfall intensity, but it's not. Of course, rainfall intensity is important. So, surface runoff. In case we have heavy rainfall intensity plus infiltration excess, it means that the soil water cannot absorb all the rainfall intensity. And so this is a question also of the soil surface. It's not only rainfall. Soil surface and the soil moisture. Both is required to assess the potential for overland flow. And I have some figures here, so one can see during the event or even after the event if there was surface runoff. Surface runoff in this regard is the one which is really the fast component, and this is the flood generation process. In large river floods, this is different. Also, the subsurface flow contributes in this regard. But for flash floods, it's mainly surface runoff. Okay, and here we have two pictures. The left one is one in Germany 5 years ago, which was very famous because I will come back to this later on. And the right one is just one picture, how you can find them all over the globe. Nowadays, it's 10 years ago in Australia. Okay, and this one, and then the concentration. If the runoff joins together, the surface runoff, and increases the discharge, the local discharge, then it can be really devastating. We have here, and so that means it's the rainfall intensity, it's the soil surface conditions, and it's also the topography. The deeper or the more steep the region is, the more relief it's available, the more hydro or hydraulic power will emerge and actually increase the velocity and the discharge. So here again, I have some pictures of our, let's say, of our famous flood in Bronstert 5 years ago. And then, of course, usually it's not only water, it's sediment and debris. It could be rocky debris or bed load, but also woody debris, as you can see here from Brazil. So it's full of wood, of woody debris. And this is also, I think, occurring in all mountain regions, including Germany. So now we are kicked out again. Sediment, you see here, the right one was, this was not an artificial pushed debris dam or something, but it was really left like this by the flood. So the sediment and debris transport is very important, and some hydrologists used to forget that a little bit, or to, but it's important, and so it's not enough if we look only in water. So it's important to work together with, for example, geomorphologists or engineers. Next one. Do you see? Yes, high damage. I see this. Okay, so we have a high damage, of course, and the point is, but I will make it clearer in a minute, I hope. Here, my right slide here. So in this community, it was a little, for German conditions, a little village of 2,000 inhabitants, a community. And the damage there was about 100 million euro. Let's call it dollars, it's more or less the same. $100 million for 2,000 people. This is 50,000 euros or dollars per capita. So the damage, of course, it depends on how much you value a house or something like this, but was extremely high. So these flash floods, because they are difficult to predict and they are almost impossible to warn, they cause extreme damage. Next one, please. So let's come to this one. The big question is also in this regard, in the media it's always discussed, how much is the contribution of mankind to this kind of events? So we have six options. We have high rainfall intensity, we have infiltration excess, as I said before, all the way down to damage. And to all of these components of such a disaster, human anthropogenic effects can be of importance, but they are importance of a different, let's say, in a different. I want to focus mainly on high rainfall intensity. We have done data analysis, so we looked on pure measured data of high rainfall intensity, not on average rainfall, but on high rainfall intensity, which you should see on the next slide. And this means we have really proven in different parts in a sub-hourly resolution. Actually, we have analyzed, and it's quite clear the data show us that the intensity of these short duration rainstorms is increasing, or, which is related, the frequency of a high rainstorm intensity is increasing. And this is shown here. The red line just shows the temperature. so which is increasing all over the world. But the high rainfall intensity is also increasing significantly. I don't go into the details of this figure, but this is a figure for 80 years now, 80 years of data. And it's very clear, statistically significant, that this type of high intensity rainfall do increase. There's evidence for high rainfall, and it depends very much also on the soil surface condition, how much rainfall can be absorbed. But these, let's say, super high rainfall intensities definitely cannot be absorbed by most of the soil surface. And in the tropics, particularly the high rainfall intensities are particularly high. They are much higher than in this humid environment as we have. Okay, let me conclude. We have done a very detailed analysis of for example, of this event in Braunsbach, and I think it's necessary, at least sometimes, to do this kind of detailed analysis to understand the driving forces, to understand the processes, and to understand the physics, the hydrological physics behind the event. And if some human settlements are, or some infrastructure is impacted, then the damage can be extremely high. Within a few hours, $100 of million within this very little catchment, which was only 6 square kilometers size, was caused. I have to say, as I said before, the rainfall intensity, or many of the high rain events are not measured. So I think if we do a statistics of this high rainfall but local events, we miss a lot because we just don't know. So that means to underrating of this kind of local rainstorms. So the probability that somewhere in our country the high rainfall intensity is caused is much higher than the usual statistic will tell us. In our case, which I couldn't show here now, this had a consequence that the estimated 100-year flood in this little village flood was about 12 cubic meters per second. It's of course not much because it's a small river, only small 6 square kilometers. But what we estimated in a post-analysis type of local investigation was about 150 cubic meters, so more than 10 times more. So there's a really mismatch. This is not, so we cannot cover it by statistics. We have to look onto the processes, very important. Okay. Of course, the human effects are important. Climate change is a fact. It is important, but there's more than climate. If, for example, land cover is changed, or especially if the damage potential is also very important. So it's because in Germany, we have some people who claim everything to change, and then the other side says, oh, nature can always do some harm. I think the truth is in between. Both we have to investigate as scientists. We have to consider both sides. Okay, ladies and gentlemen, I'm very sorry for this a little bit chaotic and non-perfect presentation. Thank you very much.